So our previous lessons, we've been talking a lot about right triangles and our trigonometric ratios, sine, cosine, and tangent. And so we took them from just the coordinate plane and started looking them at rotating and reflecting and building the unit circle. So again, just to remind ourselves, in the unit circle, we want to ask ourselves, well, what do we know about the sine? What do we know about the cosine? What do we know about the tangent? And that's going back to the definitions that we had for each of those. And we know, and talking about the sine, by definition, that's using the opposite over the hypotenuse. And when we're in the unit circle, we know the hypotenuse is always 1 for the right triangles that we use because the radius is 1. So anything divided by 1 would be itself, so we can simplify that in a unit circle saying that the sine is coming from the opposite side of the triangle. Well, think about the opposite side. That's the height of the triangle. Well, height for us would be the y's on the coordinate plane. So we can start associating with the unit circle. The sine is the y value on our coordinate plane. Now thinking about our cosine, the definition there, cosine is the adjacent over the hypotenuse. Similarly with the sine, the hypotenuse is 1 and anything divided by 1 is itself. So the adjacent for us, that's going the left and right of our origin, so that would be our x value. So we can start associating the cosine with x in the unit circle. Then when we talk about the tangent, going back to the definition, that's the opposite over the adjacent. Well, the opposite we said in the unit circle, that's our y, and the adjacent in the unit circle is x. We can start associating tangent with y over x. So let's continue working on using these key features that we talk about in our unit circle to answer some questions based on an angle measurement given to us, whether it's in radians or whether it's degrees. So let's take a look at an example. Here we want to find the sine of 4 pi over 3. So what we want to do is think about what we know based on the givens. We can see that the angle measurement is in radians. And we want to ask ourselves, well, what would the reference angle be? So kind of the clue we talked about before in radians is associating the keys for those angle measurements. And we saw things like, well, if we have pi over 3s, that means that we could start working with some 60-degree reference angles, and we could count 4 sets of those around our circle to figure that out. But if we can see the pi over 3, we know that it's 60 degrees for the reference. We just want to figure out, well, where would that be in our coordinate plane? What quadrant would we be in? So if you like thinking in degrees, this means we have 4 sets of these 60s. Well, 4 times 60 is 240 degrees, and that would bring us into quadrant 3. Some of you can just mark 4 sets of those on your coordinate plane here and know that we're in that 3rd quadrant. If the reference angle is 60 degrees, and we know that our triangles on the unit circle have a hypotenuse of 1, we could start filling in the other side lengths that we know. Well, across from the 60-degree angle in our unit circle, that would have a length of the square root of 3 over 2, and the adjacent side would have the value of 1/2. Now, because we're in the 3rd quadrant, we're going to the left and down, so both of those would have to be negative. So we have this picture drawn showing what we talked about. Here's our reference angle, the pi over 3, 60 degrees. We know our opposite and our adjacent sides based on that 30, 60, 90 pattern that we talked about. So if we're going to talk about the sine of 4 pi over 3, sine is defined as the opposite over the hypotenuse. So it's the square root of 3 over 2 divided by 1, which would be the square root of 3 over 2, and we know it's going down, so it has to be negative. Therefore, the sine of 4 pi over 3 equals a negative square root of 3 over 2. Let's try another. Here we want to find the cosine of negative pi over 3. Again, we're going to ask ourselves, well, what clues do we have? We know pi over 3 is 60-degree reference, and so we want to think, well, what quadrant would that be in? Since it's negative, we know we're going to have to count counterclockwise. So that would bring us into that 4th quadrant. So we know we're going to have our right triangle here. Again, thinking about what we did before with our right triangles, with our reference angle being 60, we can label the sides of the triangle to represent that. So again, we know across from our 60, we're going to have our square root of 3 over 2. It's going down, so it has to be negative. We know our adjacent side would be 1/2, and it's going to the right, so it has to be positive. So if we're trying to find the cosine of negative pi over 3, again, cosine is defined as the adjacent over the hypotenuse. Well, here's our adjacent, here's our hypotenuse. So we know that we're going to end up with 1/2 being our exact value for the cosine of negative pi over 3. Here we're being asked to find the tangent of 210. Well, 210 brings us into our third quadrant, and we'd have a reference angle of 30 degrees. So what we want to do is think about the picture that would go with it. We know that across from a 30-degree angle, we have our side length of 1/2, the hypotenuse is 1, and the adjacent is the square root of 3 over 2. Now, because we're in the third quadrant, we're going down and to the left, so those would have to be marked with negatives. Now we're going to think about the definition of tangent. Tangent is defined as the opposite over the adjacent. Here's our opposite, here's our adjacent. So we're going to have a negative divided by a negative, which would be a positive. And then we have to take our 1/2 divided by a square root of 3 over 2. Well, we can as such. But we don't typically divide by fractions. Instead, we multiply by the reciprocal. And again, let's think about how we multiply fractions. We multiply across. So again, we said we're going to have a positive 2 over 2 square roots of 3. Well, we can see that we have a 2 in the numerator and a 2 in the denominator, so we could divide that out and make it even more simplified, which would be a 1 over the square root of 3. Almost done, but not quite. We can see we're dividing by a radical. We don't want to divide by a radical in the denominator, so we have to rationalize it. In order to rationalize, we're going to undo this radical. So we're going to multiply the numerator and denominator by that value, the square root of 3. So we're going to have 1 square root of 3 over the square root of 9, which is 3. So here's our tangent of 210 degrees, the square root of 3 over 3. Let's see if we can find the exact value that goes with the tangent of 5 pi over 4. First thing that we did with all the other ones was think about the reference angle that we're given. So here we're working in radians. And again, we're looking for the clue in radians as to what the reference angle is. So your eye should be drawn to this pi over 4. And we know pi over 4 is 45 degrees. So we have 5 sets of those. And we want to ask ourselves, well, where would 5 45 degrees bring us? Well, each quadrant's worth 90. So you would have 1, 2, 3, 4, 5. So we're in quadrant 3. So if we drew our right triangle here in quadrant 3, again, that hypotenuse is 1, the reference angle is 45. We want to think about that when we have the triangles with the 45-degree reference angle. It's an isosceles right triangle. We talked about how the side lengths across from those 45 degrees ended up being the square root of 2 over 2. Because we are going to the left and because we're going down, we're going to show them as being negative. So this is everything we know so far. Now we're going to think about our definition for the tangent. Tangent is defined as the opposite over the adjacent. Well, this is our reference angle, here's our opposite, here's our adjacent. So we're taking a negative square root of 2 over 2 divided by a negative square root of 2 over 2. So again, this is similar to the last problem. We're talking about dividing by a fraction, which is really like multiplying by its reciprocal. So a negative times a negative, that would be a positive, and we would have 2 square roots of 2 divided by 2 square roots of 2. Well, those are both common factors that we could divide out, which would leave us with 1. Some of you maybe also noticed from the beginning, we've got the negative divided by a negative, which is a positive, and we're taking something and dividing it by itself, it's also going to be equal to 1. So you could have went straight from here to here as well. Let's try one more. Can we find the exact value for the cosine of 11 pi over 6? So again, we can see that this is in radians, and we want to ask ourselves, well, what reference angle does this radian measurement go with? So your eye should be drawn into the radian measurement. And here's our clue, pi over 6. We know that pi over 6 radians is equivalent to 30 degrees. So we have 11 30-degree angles that we're using in our circle. So if we counted, remember, each quadrant is 90 degrees. That means there would be 3 30-degree sections. So there would be 3 here, 3 here, so we're at 6, 3 here would be 9, and we're going 2 more to get to our 11. So here would be where we're drawing our triangle. So again, we'd have our hypotenuse of 1, we've got a reference angle of 30, and now we can fill in the other sides based on the patterns that we know. Well, we know in the 30, 60, 90 triangles for our unit circle, the sides opposite our 30 degrees are 1/2, and adjacent to the 30 degrees would be the square root of 3 over 2. So again, let's see what we were talking about. Here's our reference angle, and we're drawing it in that 4th quadrant and labeling it according to what we talked about. Our opposite is going down, so we're going to label it as negative. Adjacent going to the right, so it's positive. Again, we're trying to find the cosine for that angle. So think about the definition. The cosine is defined as the adjacent over the hypotenuse. If this is your reference angle, your adjacent side is here, here's your hypotenuse. So we're taking a square root of 3 over 2 divided by 1. We know anything divided by 1 is itself, so we have a negative square root of 3 over 2. That's representing the cosine of 11 pi over 6. So again, thinking about what we said, with the unit circle, the hypotenuse is always 1. So the sine and cosine, typically if you're dividing it by 1, it's always going to be the value in your numerator. Cosine is the adjacent side. So if you remember that, cosine of 11 pi over 6 would just be the square root of 3 over 2. You can go straight to that point there. Again, for the sine, that's your opposite of a hypotenuse. If you could just see that opposite side, that would be your result. And the tangent might take a little bit of steps because you're doing the opposite of the adjacent and then simplifying, making sure that everything is completely rationalized. So now it's your turn for practice. If you look at the next page, you have 6 problems. What you're going to be doing for those 6 is doing what we did together. Based on your trig ratio and the angle, draw it and find the reference angle. Then make the sketch with the right triangle, labeling the side lengths as you're given based on the reference angle, and then you can complete the exact values. So it's asking for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. With our unit circle, we know the hypotenuse is 1, so the sine opposite over 1, that's just going to be your opposite, which is your y. Cosine adjacent over the hypotenuse, so adjacent over 1, that's going to be your x. Tangent opposite over adjacent, that's your y over x, and you can simplify it accordingly. Things that will make this process go a lot smoother is if you remember your degree measurements for the unit circle. So the basic references are 30s, 45s, and 60s, so you can build those as you go around your circle. You also need to know their corresponding radian measurements. So we know that pi over 6 is 30 degrees. We know pi over 4 is 45 degrees. We know pi over 3 is 60 degrees, and we can use those to help us go around the circle as well. So it's your turn to practice, finishing up your Day 11 worksheet 1 through 6.